Hello and welcome again. In the second video of the series, we are going to build a LangChain application with local embeddings and a local LLaMa model. Let's get started. We run both the embedding model and LLaMa on GPU, so for this video we will be on Google Colab for a better reach. We will work on a T4 GPU, a general purpose mid-size GPU, which is freely offered by Colab. We start with the requirements here. We will run LLaMa quantized to 4 bits, so we need bits and bytes library, like here. Bits and bytes enables accessible large language models via k-bit quantization for PyTorch. So this library provides 3 main features for dramatically reducing memory consumption for inference and training. Today we are going to do inference. Basically, we want to quantize LLM weights to 4-bit integers instead of floating points to take up less computation time and burden. If you want to learn more about quantization of the LLMs, I have one more series called Practical LoRa Recipes, and I left the link below. In order to run bits and bytes, you need the latest version of the transformers, so please do not forget to run this line. Okay, next we have the LangChain installs. Here, we already saw these installs from the previous video. LangChain Hugging Face is new here. We use LangChain Hugging Face functionality to employ the embedding model and the local LLaMa. Rest of the code is identical for the first video. Only embeddings and LLM sections are different. I ran these 2 cells already, so we have everything installed. This time we use a different loader, web-based loader, because this time we are going to use the web pages directly, the ones that we used in the previous video. This line go crawls and parses out these URLs and offer their context as text. For playing, I also made chunk size a bit bigger, for now 1000 characters, and I slide it by 200 characters. Now comes the first local part, local embeddings. Right here, we use this model, which is a sentence encoder. Indeed, this model. As I said, this is a sentence transformer, transforms a sentence, and you get a final vector representing your sentence. This is the dimensionality, and this is the number of parameters, 22 million, which is comparatively small these days compared to the LLM. If you look at the model, this is basically a BERT model with a pooling layer on top. So basically the model pulls word embeddings to output a final sentence embedding. If you need more information, please have a look at the sentence transformers documentation. I left a link below. Now comes the question, how do we use this model? LangChain Hugging Face offers this class, Hugging Face Embeddings, literally to use sentence transformers in LangChain ecosystem. This class is a wrapper actually. Here, it calls the underlying model's encode method to embed the text. And here is this class from the source code of LangChain Hugging Face, and here is embeddings. Here it is, the class. Come. And you are going to see an init, an embed, and other methods to embed the documents and to embed the query, which embed just calls the underlying model's encode method. Okay, we jump back. So it is a wrapper, as I said. Going back to the code, we give the sentence transformer model, this one, and some arguments. I would like to encode our text on GPU, so I pass the device as the CUDA 0 here. If you don't have a GPU, skip this line. But we have a GPU. Please try to land onto a GPU. During creation of the vector base, we pass the embedding function, just as before, accordingly, and create our database and persist it. Let's do this. Let me refresh. Here is our persisted database. Looks good actually. Great. Next, we play with the embeddings a bit. Again, we have some strings that we want to encode with our brand new embedding function, remember a sentence transformer just lies behind. Once we call embed query, here we get an embedding per string. Then we calculate the distance between the pairs by calling cosine similarity, and then if you make a 1 minus similarity, you get a distance. Obviously, computer is closer to Alan Turing rather than a screen. Very cool, right? Okay, now we can throw our query just as before. Here it is. Number 1, we ask for top 3, number 2, and number 3. They all look relevant. Great. Now comes the LLaMa part. We will define our prompt template just as before in the first video. We will plug in the fetch context and then the query. Let's click it. LLaMa, I clicked already. So we are going to go over the material right now. Now again from LangChain Hugging Face, we import a Hugging Face pipeline. Then we will do this line of import from transformers to employ and download the LLaMa model. Today we will use the 1 billion model that is lightweight but still delivers. Here, as long as it's a causal LM, so it fits here, you can plug in anything you want. DeepSeek, Mistral, QN, or any other model you want. One tiny detail that you need for the LLaMas, you need this environment variable, Hugging Face token, to access the model, but you also need to ask access to the model from the model's Hugging Face page. You can get the access from the model's Hugging Face repo. I ran this cell already, so I have the model. But if you do it for first time, it may take a tiny bit of time for your download. Okay, first we download the model, we place it onto GPU and load it in 4 bits. Device map equals auto will handle the GPU. If you have multiple GPUs, this line still handles placement of your model onto your GPUs. So if you have multiple GPUs, this code will work anyway. Perfect, now we define next text generation pipeline from Hugging Face. Then we pass this pipeline to create a LangChain Hugging Face pipeline. Just like embeddings wrapper, this class is a wrapper too. It calls the underlying pipelines generate method. Rest is really easy. Then we call invoke method on the LangChain pipeline object and pass our prompt. Here is the result. Here it is. Let me go over it. So this is context. Everything we fed. This is question and this is the answer by the LLaMa. Well, looks good actually. Looks polished. Great. And all this is the sources that all 3 contexts came from the path model config one. Please do note that you need a GPU for quantization and also placing LLaMa because it's a giant model. That is the reason today we worked on the collab. Okay, that's it indeed. I hope you enjoyed the content. If you have questions, please put them, just shoot them in the review section. For the next video, we are going to use with a multimodal model, which is like very similar to this code, but embeddings and also the LLM will be different.